I want to go into a bit detail about the conventional diesel power supply, especially in regions in Southeast Asia. The diesel generators are still a very common source of energy. So on islands, but also for industry, production, tourism and production, you'll have, in many cases, you'll have diesel generators running to provide electricity. And you know, the downside of that form of energy generation is that you consume a very high amount of fuel to supply yourself with energy, and that comes along with a very high cost of electricity. So in addition to the fuel cost, the generator always generates also costs for operation and maintenance, which come into the energy price. If it's a project or an application on an island, you'll first have to get all the diesel fuel on site. So that's also a difficulty in many locations. And of course, burning fuel is not the best for the environment, so you're generating a lot of CO2 emission and impact in terms of noise and exhaust fumes. And the downside about high power applications, so industry applications where the generator has a high capacity and it's a constant source of energy, it's that so far it was not possible to integrate solar or renewable energy systems on industrial scale because there are also always issues with battery storage and the battery inverters, as they cannot cope with the high power demands of many applications. So what you see here is a typical application for an industry, let's say, which is powered on diesel generator. So you have the diesel generator here supplying the load, the factory and associated buildings with energy. And due to the fact that you're burning diesel fuel, you'll have very high cost of electricity. So what we did, like 4 years ago, we started developing a system that allows us to integrate renewable energies into conventional energy networks. So it means we developed a control solution that combines the two energy sources and supplies the load from a combination from conventional power, diesel power or grid power with renewable energy. And in that setup, we do not need batteries. That's the advantage. It's a direct combination. So during sunshine hours, the solar energy is feeding into the internal electricity network of the application. And the diesel generator only has to provide the minimum energy, the base load. So it means the less energy a generator provides, the less fuel he consumes. And this is where the economics come into play. And as we do not need batteries, the investment costs are roughly half of what conventional off-grid systems require. So that combination results in 40% fuel saving and also 40% reduced CO2 emission. And I think words speak more than any other theoretical documents or whatever. I want to show you just an extract of recent projects that we are installing or that we are already installed. And that's one example for an installation on an island. It's in the Maldives, in the south of the Maldives. It's an island where local people live, so a local inhabitant island. And you'll see a small map down there of that island. And the south, you have a utility powering the island. So they have approximately 3 megawatt of diesel capacity installed on that island. And the energy gets distributed over an energy network that is around the island, buried in the ground, to all the applications, cables going to all applications. And what we are doing, or what we did already, what you see on the picture is actually taken from the project. There are 5 locations on that island where solar has been implemented. This, what you see on top here, is the south of the island where the powerhouse is. You can see here the exhausts of the diesel generators. And on 4 other locations we implemented solar. So the total capacity is around about 1 megawatt of solar. And we implemented our control system that takes care of the combination of the two energy sources. The solar sites are connected over a almost 4.5 kilometer long data network that is installed on the island, so industry data network. And that control system that is installed takes care that the solar penetration in that energy network is always in the right level, so that the generator is not running below its minimum loading, is not running in a bad combustion, the control system is also preventing that you have a backfeeding on the generator. So overall, that utility on that island is saving roughly 1,000 liters of fuel per day, which results in a return on investment of 3 to 4 years in that project. That's a reference installation from the industry sector. This is in Namibia. The client there is Namibian Breweries. That's the largest brewery in Namibia. It's partially owned by Heineken Group. That project was implemented in October last year. That application, the brewing process, is running on both public grid and on diesel generator. So when the public grid fails, the brewery has to switch to the generators that they have installed because they can't stop their brewing process. And we implemented that project, what you see here, in only 6 weeks total construction time. And it's covering the roof space of the brewing facility. So during connection to the public grid, they are offsetting the major part of the electricity what they would normally buy from the utility. And in times where the public grid fails, the energy from the solar system, it's getting operated in combination with the diesel generators, and they are saving 40% on fuel consumption. They're using a combination of diesel and heavy fuel oil, so it's quite economically attractive for them. One side effect that also came into consideration when constructing the system is that you can see that the whole roof surface has been covered with solar panels. That means it's a form of insulation of the roof. So we measured before and after, and the inside temperature of the production facility is around about 5 degrees Celsius lower than before. So additionally to the energy savings that they generate from the solar system, they also have additional energy savings through the lower temperatures, so they need less energy on the ventilation and air conditioning that they have inside the production, which is a nice side effect. By the way, it's... This project is, speaking today, still the largest rooftop installation in Africa, and by the time it was constructed, the world's largest hybrid system of that kind. And now coming to projects, you see we are slowly moving towards Southeast Asia. This is Mauritius, that's currently under construction and will be finished in 4 weeks' time. This is for one of the biggest supermarkets on Mauritius. It's a similar roof that you can see from the Namibian breweries. The operator of the supermarket is also running on a combination of both grid and diesel generators. So the principle is similar, but there is one technical feature in this project which is quite unique, because instead of deregulating the solar power in the hybrid system when we are running in a combination of diesel and solar, we are taking the excess energy of that installation and we store that excess energy in a cold water storage. Because you can imagine that in a supermarket, in a mall, the highest load is for air conditioning and ventilation and cooling. So what we take the additional energy that we normally would have to deregulate and that would have got wasted. We take that and store that in cold water. So the chillers from the air conditioning system can take that energy in times where the solar radiation is not at the peak, so in the morning hours or in the afternoon. And that results in significant additional savings for the operator of that supermarket. And of course you have the insulating effect of the solar on the roof as well. One of our longest operating systems already. This was implemented back in April 2013. This is for a hotel on Haiti. There is grid available on Haiti, but the grid quality is so poor that the operators of the hospital had to change to diesel power supply because due to the bad quality, they constantly lost their equipment to the peaks on voltage. So they are supplying themselves with diesel generators, but this results in very high fuel costs. Fuel is expensive there. And we implemented the system back in April 13, and the system is up and running since then. And we did measurements on the fuel consumption, and we are really saving 39 to 40% in average per year, which the hospital can use for reinvesting in medicine, in stuff, in extension of the location, because they need the money better than being burned in diesel fuel. All the applications that I've been talking about is for industry scale projects or large scale projects. But we also have a solution for smaller applications, because we've been approached many times by clients having smaller generators, and they don't need the large-scale extension of our control systems. So this is why we came up with the compact version of our control system. And this is a limited power application up to 55 kVA on the generator side. It implements up to 25 kilowatt on the solar. The good thing is it comes almost plug and play, so you connect the generator on one side. It's all pre-installed with fuses and terminals inside the controller, so it comes the AC from the generator inside, it comes the AC from the photovoltaic inverter inside, and the system automatically detects in which load ratio the generator is running, and depending on that, it's deciding how much solar energy is being fed into the grid, in the local energy grid. So that also results in fuel savings of roughly 40%, depending on the application. Project from a different angle, what you see on the brochures. Basically, it's two roofs. So there's one brewing hall, and the other one is where they burn the fuel to get energy. So you see it. No, we are we're neutral both on solar modules and inverters. So our key point and IP is the control system. So we are flexible. So in some projects we do the full EPC, where we bundle the whole package for the client, but we also come in projects where other companies doing the EPC, and we're coming in for the control system. Yeah, these are the generators from the Namibia project. This is where we feed in the local energy distribution. This is what you have seen in the slide, basically. This is the power supply before we integrate our high grid control system. So 100% comes from diesel fuel. And when we integrate the solar, we can offset 40% of that energy by solar energy. You may ask why not 100%, because we have to still run the generators at the minimum loading to not run them in a bad combustion range. That's why we typically offset 40% on fuel. But that has the advantage that we don't need batteries. So the average return is 2 to 4 years in our projects at $1 per liter on fuel. And as we don't have batteries, the service life is 20-25 years on the systems, as you know from grid-connected solar systems. That was the case that you just mentioned. If it's in grid connection, we can offset even more, because we don't have to use, we don't have to consider the minimum diesel loading. We also did the SCADA integration for the brewery. So our system comes with a full SCADA system, industrial standard communication protocols. So we integrated that into the SCADA control room of the brewery. So the control system always measures in real time what is the application, the load profile of the application, and depending on these measurements, the system decides how much solar energy is being used. So I said to keep the operation stable and highly efficient. The system can be implemented in systems with multiple generators, so there is no maximum generator capacity or no maximum generator size. There's also no maximum solar capacity in that system. And this is how the impact of the solar goes on the load profile. You see, this is a load profile for an application that has mainly day loads. So they're starting up in the morning, putting up their machinery, and they're closing down in the afternoon. And what you see there is the impact of a 1 megawatt solar implementation. That's roughly the size for that Namibia project. And you see the load curve gets moved down, and that results in that energy saving. And in that application, it's the 1 megawatt system. It's over 500,000 liters of fuel saving per year, which you can imagine is a high cost factor for the operator. You see, to sum it up, it's 40% fuel saving. That's why with the attractive investment cost, we can achieve very attractive payback periods. The size can be extended, so the control system is in place and the system can be extended from, let's say, 100 kilowatt to 2 megawatt without significant changes on the control system. And these are some additional pictures from our projects. This is another installation on Mauritius that you see there with the landmark building. It's Mauritius Commercial Bank. The picture next to it, it's on in the German Alps on the mountain Zugspitze. These are some pictures from our West African partner company. Yeah. So thank you very much for your attention.